Alright, so we're going to finish up section 7.2 by talking a little bit more about bias and standard error. If the following conditions are met, so our first condition, our sample is randomly selected from our population interest. And then our second condition, if the sampling is without replacement, the population must be at least 10 times larger than the sample size. So if those two conditions are true, then the bias of our p hat is going to be 0. Again, p hat coming from our sample. This shows accuracy. And then we're going to get a formula for our standard error of p hat. Right? Our standard error has to do with precision. Right? And when we're getting for our standard error formula, if we know our population proportion, then we can plug our population proportion in here for p. If we don't know our population proportion, we can estimate it using our sample proportion. So this little EST means we're estimating using our sample proportion, which if we see this little EST here for our estimation, that means that these p's need to have a hat on them because they're coming from our sample instead. All right, so according to the Mars Company, packages of M&Ms contain 20% orange candies. Suppose we sample 100 random candies. So if our following conditions are met, our sample is randomly selected. Yes, our sample is randomly selected. And our population must be at least 10 times larger than the sample size. We can pretty much assume that that's going to be true here if we're just taking a sample of 100 candies. Right, what should we expect for our percentage of orange candies? We should expect 20%. Right? What is our standard error? Well, here we're going to use our formula that we just saw above. So our P, our percentage that we're expecting, is going to be our P that we're going to plug into our formula here. So P is 0.20. Then we're doing 1 minus P, so 1 minus 0.20. So we're multiplying our percent times its complement, divided by N. N is our sample size, which is 100. Right, this gives us 0.20 times 0.80 after we do that subtraction, divided by 100. At this point, if you can, I might plug this into your calculator now. I'm going to work through this all the way, showing every little individual step, but you're, for the most part, going to want to be a little faster to get these into your calculator. We multiply 0.20 times 0.80, we get 0.16 divided by 100. This is going to give us 0.0016 if we divide that out, and then we take our square root and we get 0.04. I purposely picked numbers that work out really nicely so there's no rounding or anything. However, in a lot of the problems there will be rounding. So again, the more of this we can plug into our calculator early on, that's definitely something that you're going to want to practice. Okay. So how do we interpret these values? Well, we expect 20% orange candies, right? Because according to the company, that's what they contain. Our standard of error gives us our amount of spread. So we should expect 20% orange candies, give or take 4%. Right? So that is our standard error, and that's how that all links in. Again, we'll be using the standard error formula as we move into problems in the next couple of sections. So the more comfortable you are with plugging these in, using your calculator to find these, the better off we will be.